Okay, so today we discuss the last chapter, project management. So the objectives are to know the principal tasks of project managers, which you'll eventually hopefully become after you work as a software engineer for a few years, and understand the need for project planning and how to staff and schedule projects, how to estimate size and cost of software development, understand the notion of risk planning and management, and project tracking and control. So the challenges of managing software projects. Project management happens all throughout the software development process. So it's a lumpy shape at every stage of the process. So the challenge is to upfront we need to create a project plan. Well, to have to deal with incomplete knowledge of requirements, people, etc. Requirements are often incomplete at the beginning. Clients often submit changes of requirements during the project, and people may come and go during the project. So limited resources in terms of time, money, and skills. Decide about development issues like what features are required. This relates to the requirements whether to buy or build. So for example, for small embedded systems, many times you can build your own operating system because it's very simple. Or you can buy a commercial operating system. So of course, building it saves money. Sometimes it saves money. Sometimes the engineer's salary could make it not worth it to build it. And what resources are required, the risks, the tasks to be done, what effort to expend, what schedule to follow, what development tools to use. So tools are important, especially for small-scale projects. They're often more important than the processes. So planning and development is a continuous process. We need to plan the work and work the plan. That is, you're continuously revising your plan as the project goes on. So software development plan, SDP, documents how the project will be managed. It defines the project. So inputs are needed from development manager. So this is the person who's responsible for overall project organization and budgeting, etc. That's the project manager. Experienced system architect who defines top-level packages and estimates sizing of the project. So how many lines of code, how many developers, how long it takes. Expert user or domain expert, that's the client who provides requirements understanding. So you need to define the scope of the development by defining the problem to understand what the client wants, and then analyzing the requirements to make sizing estimates. So sometimes you need to make intelligent guesses as to how large a particular subsystem is. So it's a constraint optimization problem where you have a limited time and money budget, and you try to satisfy the most critical requirements of the users. preparing a top-level package diagram to have an overall system view. This is done by the architect with understanding of the requirements and past experiences. So the architect is a title that you earn after many years of experience. So you don't become an architect right after you graduate. You need industry experience after working on many projects in order to be a good architect. By the way, Bill Gates' former title while he was working at Microsoft is the Chief Software Architect, not the CEO. So estimating the time and effort needed to deliver this product. So we'll talk about estimation in a bit. It's a difficult job, and oftentimes estimation can be very inaccurate. So, and the outcome is a go, no-go decision. After you decide on the problem size and your budget, you realize perhaps it's not realistic to finish the project within the budget. Then you make a no-go decision. Otherwise, you make a go decision. So work breakdown structure breaks down the project into tasks, subtasks, so to ease planning, divide and conquer. So here's an example. So the project is divided into several high-level tasks like initiation, that is negotiation with the client and seek management approval, and tracking of the progress, development, maintenance, and training. So within development, you have, if you're using the unified process, you have inception, elaboration, construction, transition, 4 tasks, subtasks. And within each of the subtasks, you have builds. A build is an intermediate build of the software, which is executable. Or perhaps you are doing a build in the inception phase as a rough prototype, and you're doing incremental builds as you go along the elaboration construction phases. And finally, you have packaging and installation at the transition phase. And within each build, you do a bunch of sequential steps: requirements analysis, design, implementation, testing. So this is the waterfall. This is the unified process where you do vertical steps through requirements analysis, design, implementation, which results in the build, and you do another vertical round of requirements to testing, and each vertical round pushes you along the horizontal line towards from inception to eventually to transition. So identifies all the activities, tasks required to complete the project, estimates resources required for each leaf node, and rolls up to get the estimate of the entire project. So you do this from bottom up. Add up the lower level estimates to obtain higher level estimates. So used in budgeting and scheduling. So budget is the monetary cost, and schedule is the time estimate. So work breakdown structure should allow each task to be easily planned, so that each task has a well-defined start and end. So you have well-defined deliverables at the end of each task. For example, at the end of the requirements, you should have a requirement specification document. At the end of the design, you have a design document. At the end of the entire requirements to design to implementation to testing should have a build. So you know that this task has been finished. Easily assigned to individuals and teams so that you can divide up the system into subsystems and give each piece to a sub-team within the project team. Track to monitor progress and to know who is working on it. This is project tracking. And budget it so that costs can be tracked. So, and of the right granularity, so if it's too small, granularity is hard to track. It's too large, then it's hard to control costs and measure progress. So there's a term called micromanagement. That is, you're managing the developers at a too fine-grained level. You're say you're requiring him to submit a progress report every 2 days, or every week is okay, and then the developers get very annoyed that you're tracking his everyday progress. On the other hand, you shouldn't leave the developers alone and only do some weekly meetings or monthly meetings. Then developers tend to slip in their tasks. So you should strike a balance between the as to the granularity of the each task for monitoring and control. So SDP defines a hierarchical project organization, identifies project roles and responsibilities. Many roles available are possible, like architect, designer, programmer, tester, etc., QA engineer. And you plan the number of staff in each role. Estimate establishes teams as needed. So may need interdisciplinary teams to coordinate certain efforts. So perhaps a development team and a testing team. That's the most common division of teams. Perhaps you have a few people dedicated to documentation, a few people dedicated to UI, etc. So one project member should have experience with a similar system. So hopefully it's the project manager, but otherwise you should have someone who has done something similar before. So to minimize risks during the project. So the team organization should be modular to limit communication and complexity of interaction. So modularity means that you minimize the coupling between the modules. Therefore, the division into teams should try to minimize the communication needed. Of course, they should communicate, but they shouldn't talk too much. If they require a lot of communication, perhaps you should put them into a single team. Assign clear responsibilities to each team member. So invest each team member with a sense of ownership. That is, say, give a particular small subsystem to a member, to engineer, and anything that goes wrong with that subsystem is that guy's responsibility. So it's kind of like his baby, and he needs to take care of. So this implies that teams should be formed to have responsibility for the design and implementation of one or more packages. Divide the teams at the package boundaries. Then there's likely to be less communication among them. Classes should be assigned to individuals for design and implementation. So each individual is responsible for a bunch of collection of classes. A pick, a person in charge, should be identified for each package and the system, so you know someone who to point fingers to when something goes wrong. So achieving the right level of communication is a key to success. Too much communication means that the developers are distracted from the actual work. Too little communication means that perhaps you're not tracking the progress very accurately. So the SDP defines the project schedule when things happen. Task ordering, dependencies including sequential and parallel. We'll discuss the so-called PERT chart later that describes the dependencies between different tasks. Time estimates for each task, including start time and likely duration. Resource assignment, including human resource like people and hardware software resources. Milestones, that's the management decision point to gauge the project progress. Deliverables, specifications, including requirements, specification, design, and other specifications. Documents like user's manual and documentation of code and code. So critical path is the chain of tasks that determine project duration. That's the longest sequential chain of tasks. We'll see this in the PERT chart. So 3 levels of schedule are maintained. You have a master schedule for management and communication to the client. So it's a rigid schedule. It's a very coarse-grained schedule. Includes major milestones, demonstration to the client of system builds, and project reviews. So these are rigid. They cannot be changed. So macro schedule is semi-rigid. That is, it's for day-to-day project management. It's reviewed and updated monthly it contains all the elements of the master schedule plus any of the internal schedules in a development organization, like development phases, test planning, and internal milestones. So micro schedule is for team management. It's highly flexible, created during the execution of the development phases. So it is usually not part of the formal project plan. So it's rather very fine-grained schedule, like say a developer A needs to finish this module before Wednesday, right? So that's something that's very informal and created and executed as the project goes on. So Gantt and PERT charts are commonly used to manage schedules. So we saw Gantt chart before. So I think there's a hidden slide. Yeah. Turn off. Gantt chart. It's a visible representation of the planned tasks and events. So you have the horizontal line as the time in terms of number of weeks, and the tasks are on the vertical axis. The blue part indicating completed tasks, and yellow part indicating incomplete tasks. So as the time goes on, you should try to also move the blue parts forward. So another type of chart is PERT chart, Program Evaluation and Review Technique. It's a graphical representation of project tasks laid out in the form of a critical path network. So here's one example. You have a bunch of nodes and connected with edges. The edges are indicating the tasks, not the nodes. So you have tasks A, B, C, D, E, F, G. Each task has a duration. You may add dummy tasks to ensure that each node has at least one task starting and one task ending at the node. That is so this task takes 0 time. A dummy task takes 0 time. Its whole purpose is to make the graph look uniform. So to indicate a precedence relationship, that is, say, C has to finish before E. So C has to finish before E. If you don't have this dummy task here, then C may drag on until the very end. But by having this dummy task with 0 duration, you enforce the precedence constraint. So the critical path, so each task has a duration indicated here. A has duration 1, could be 1 week. B has duration 3, and C has duration 4. So, and the red arrow indicates the critical path, the longest time path from start to end node. So it is the longest sequential path. The overall schedule length depends on the critical path. Because for nodes that are not on the critical path, you can always do them in parallel. You can assign more developers to hide say task C and task F's latency by doing things in parallel. But for the tasks on the critical path, they must be sequential. So assigning more resources to it won't help. So it defines the longest schedule. So estimation is try to quantify something before it occurs. So in the PERT chart, we saw the duration of each task, but how do you get the durations? So you have to do it before the system is built. So you have to make some intelligent guesses. SDP provides estimates of a size in terms of lines of code, number of subsystems, number of classes. So this is the estimate because you're doing it before the software is written. And effort in terms of a person times duration could be a person days, could be a person weeks. Productivity in terms of size divided by effort. So for example, 1,000 lines of code per day per developer. That's a productivity estimate. Duration in terms of months until delivery. Development cost in terms of labor cost. Monetary budget. So estimation is based on experience, historical data, and courage. So courage means that you're trying to derive a quantitative measure when you only have qualitative data. So you're trying to make a guess. So estimating carries inherent risk. We try to minimize the risk as much as possible. So the risk means that the inaccuracies of estimation. So they can be due to high complexity of the software project. So lack of historical data, a lack of experience in the application domain, they can all contribute to estimation risks. The risks associated with estimating is reduced if we establish project scope in advance. So try to define the project scope in terms of what is within scope, what is outside of the scope, instead of adding new contents to the scope during the project. Using metrics from past projects, divide and conquer by breaking the project into small parts and estimate and sum. It's always easier to estimate a small module than to estimate a large one. So the client needs to recognize the variability and uncertainty in the software estimate. So estimating is based on metrics. So we can collect many types of metrics about many aspects of software. So technical metrics indicates how the software conforms to requirements. Quality metrics indicates how the software conforms to how good the software is, essentially. What's the bug rate? Does it crash often, etc.? Is it easy to use? That's all the entities we discussed before. Dependability, reliability, etc. Productivity metrics measures the developer productivity. That is, it includes two parts. So both size-oriented and function-oriented metrics are part of the productivity metrics. So the size-oriented metrics are measures of software development, output, and quality. And function-oriented metrics are indirect measures, not from the source code, but from the functionality, which we'll show an example next. So finally, human-oriented metrics are the information from people, from the developer's point of view, how effective are the tools and methods used. So what metrics are useful for estimating and how they can be used for estimating. So we'll discuss size-oriented metrics and function-oriented metrics, two examples next. So estimates are based on data from past software projects. So for example, in the past, project L1, that's the project name, has cost $168,000, has 12.1 kilo lines of code, 12,000 lines of code, has 365 pages of documents, and number of errors is 29, number of people is 3. So different project has a different statistics. So now you have a new project, you need to make an estimate on the effort. The effort could be person weeks. So this project A has 24. So you can use the this column, kilo lines of code, to as the metric a size-oriented metric. It's size-oriented because it measures software size. And to estimate the quality as errors per kilolines of code. So, say if you have 29 errors for 12.1 kilolines of code, then perhaps if your new project has 6 kilolines of code, perhaps you have 15 errors. So, and you do this with a simple linear relationship based on the lines of code. So what is the problem? Because different projects are very different. So the key lines of code is a very inaccurate metric. Some projects you may have huge amounts of mundane simple code. Therefore, the lines of code is very large, yet the error rate is very small. Some projects may have very complex control structure, very high cyclomatic complexity. So it may have a very small lines of code, but may have many errors. So lines of code is really a bad metric. So another metric is a function-oriented metrics, where you measure the number of user inputs, number of user outputs, number of user inquiries, number of files, number of external interfaces, and multiply it by a weighting factor depending on how simple, average, or complex the inputs, outputs, and files are. So the user inputs counts each user's input to provide distinct application data to the application, to the software. User outputs are the output dialogues and anything output from the application. Inquiries are the queries without updating the application data. So, and then you obtain a count total based on the weighted sum of all the different counts, which is here. And then you multiply the count total with this magical number. So this magical number is 0.65 plus 0.01 times sum of fi. So the fi is so-called function-oriented metrics. So here's a slide on the different inputs, outputs. Number of user inputs counts user input that provides application data. Outputs counts application-oriented outputs, etc. So metrics, including these 14 are examples. You can have more. F1, does the system require reliable backup and recovery? And then you rate this particular metric by a number from 0 to 5. So if the reliable backup and recovery are essential, you give it a 5. If it's really not that useful, you give it a 1 or 0. So are daily communications required? You give it a rating of essential or no influence. Are there distributed processing functions? Is performance critical? Etc. So each of the questions you give it a rating of 0 to 5, and then you sum up all these ratings into a single number, multiply it by 0.01 and plus 0.65, and multiply it with count total obtained with a weighted sum of all the input-output interfaces parameters. And then this is the function metric, function-oriented metric. It's called a function point. And then you estimate all the others like productivity, cost, quality, documentation based on this number, function point, instead of the lines of code. So why do you have this formula, and why is there 0.65 instead of 0.7? These are all experience, based on experience. This is a heuristic formula that's been shown to work well. You may have other formulas that can also work well, but this one seems to be okay. So there's really no hard science behind it. So these two examples are the one is the size-oriented metric, one is the function-oriented metric. Both are productivity metrics for measuring, for estimating how much time and how many people are needed for a particular task. So estimating incomplete and imprecise requirements hinder accurate cost estimation. Of course, if the requirements are incomplete, it's hard to know how long it takes to finish requirements. Research requirements should be developed incrementally under uncertainty. So you shouldn't do a big bang estimate at the beginning and leave it as it is. You should try to update and modify your estimates as your project goes on. You revise your estimates. Good estimation model is doing well if it can estimate software development costs within 20% of actual costs, 70% of the time on its own turf. Meaning that it is estimating for the company's own projects. So this is just saying that cost estimation is difficult, and it is already very good estimate if you're off by 20%. Estimation should always be performed in more than one way, and the results cross-checked. Perhaps you've done the estimation with the lines of code metric, and you do it with the function point, and you compare the results. If there's a large discrepancy, perhaps you should revise the estimates. It is essential to have experienced developers to do the estimating based on his past experience. Automated tools can help reduce the effort required. There are tools called Kokomo, which you'll probably hear about if you become a project manager. Essentially takes into as input different metrics and produces the estimate as to how long a task takes and how many people are required, etc. So now we discuss risk planning. So T. Gilb is this software engineering researcher who says if you do not actively attack risks, they will actively attack you. So the SDP plans for risk by trying to foresee what can go wrong before it happens. Estimates its likely impact and estimate the likelihood that it could happen and develop cost-effective contingency plans. That is Plan B. if something bad happens, do you have a contingency plan to fall back on? Perhaps by cutting some features or some other cost-cutting measures. So the ability to do this well is one of the important qualities of a good manager. Risk planning is related to preventive management. That is, determine the risk and execute preventive action before the problem occurs. Try to foresee problems instead of handling it in a reactive mode. If you know the enemy and you know yourself, you need not fear the result of 100 battles. This is a Chinese proverb. It says, 知己知彼，百战不殆. Right? So risk projection and estimation. So for each identified risk, we need to estimate the likelihood that risk will occur. So establish a scale, either Boolean, yes or no, or subjective, like improbable or likely, probabilities like 10% probability or 30-50%. The consequences and impact of the risk is nature. What is the risk? What's going to happen? Its scope in terms of what's likely to be affected and to what degree. So if it's it combines the severity with its overall distribution, that is how serious it is and how much of the project will be affected. So if it's confined to a small scope, to a small subsystem, perhaps it's less serious. But if it's cross-cutting through the whole project scope, then it's more serious. It's timing, so when is it likely to happen and what will be its duration? Is it likely to happen at the requirement stage or at the testing stage? And third, you need to estimate the accuracy of the projection. What is the basis for the likelihood and impact of the risk? You give it a likelihood of 50% and a high impact. What's the rationale behind it? Why did you make that decision? So prioritize risks by perceived impact on the project. So prioritize risks by the impact number here and try to deal with the high impact risks, the showstoppers, and leave the low impact risks later to the project. So example risk is high staff turnover. I is this subscript for indicating the particular risk. So with the likelihood of 70%, so the impact is the increased duration of the project by 15% and overall cost by 12%. So that's the R, L, and X in the previous slide. So what steps can be taken to mitigate the risk? So you can try to have regular meetings with staff to determine causes for turnover, and once the project starts, assume turnover will occur and develop techniques to ensure continuity in case there is turnover. For example, by providing good documentation for the code developed, so that someone new who comes on board can quickly start to be productive. That mitigates the risk of personnel turnover. or you can conduct project peer reviews regularly so that everyone is up to speed, so that if one guy leaves, someone else can take over. So we need to perform a cost-benefit analysis of the countermeasures. So do they cost more than the consequences of the risk itself? If yes, then perhaps you shouldn't do the countermeasure. So, for example, one measure could be to define a backup staff member for every critical staff member, so that when the critical staff member leaves, the backup can take over. But if that costs a lot of money, then perhaps it's not worth it to define a backup staff member. Applied 80-20 rule, 80% of all project risk is accounted for by 20% of identified risks. So try to identify the 20% and prioritize the important risks. Identify and closely monitor these 20%. So, time-phased budget. So SDP specifies a time-phased budget that details when the project budget is planned to be spent and what is expected to have been accomplished at each level of expenditure. So instead of a lump sum budget, say $1 million for this particular project, you should make it time-phased. That is, after 3 months, you should have spent $300,000 and should have a functioning prototype with most features, etc. So that you can track and monitor the budget and its progress of the project. So manpower will likely to be the major cost for software development projects, because computers are cheap. Perhaps the software tools will cost you some money, but it's typically small compared to a cost of salaries. So you should assign each the item in the what's it called? Work package, work breakdown package. So work breakdown plan to assign a cost for each item based on duration, staffing level, and cost for each type of staff. Obviously, a senior architect costs more than a junior developer. So there are other costs like training, software licenses, hardware, and others, plus some reserve between 10 to 15% to leave room for any unexpected costs. So track the spending by comparing a plan against actual money spent and plan against actual completion of tasks regularly. So at a particular level of spending, you should have completed a particular set of tasks. So project tracking and control. So software projects fall behind schedule 1 day at a time. Therefore, you should track the progress, day-to-day progress. So there needs to be a constant, consistent, inoffensive monitoring of project activities. So the project manager must keep track of the progress of the project constantly, but at the same time, the keyword inoffensive means that you shouldn't really annoy the software developers. Ask them every day, how is that module doing? Have you finished it yet? And then developers may get very annoyed. So the primary purpose of monitoring is to make sure that the project is meeting the budget and schedule. So change is almost inevitable despite the best efforts to minimize it. This includes requirements change, design change, analysis model change, and implementation change. So therefore, the key is to handle changes in a controlled manner. Apply software configuration management. We discussed SCM for change management. Essentially, you have a check-in, check-out system. You have peer reviews before the change is applied, etc. So, adding manpower to a late software project makes it later. This is the Fred Brooks, who's the famous software engineering researcher, written in the book The Mystical Man Months. So The Mystical Man Months is a famous book for project managers. Man months is this productivity metric. That is, how many lines of code can a person develop in a month? So the mystical man months essentially says it's very difficult to estimate this particular metric. That's why it's mythical. So adding people to a project makes it later because you need to train the new people and bring them up to date, up to speed. That takes time and takes resources and time away from the existing developers. And the more people, the more communication overhead is required. So perhaps if your project is late on schedule, if you have 4 people add a new person to you who has not done anything related to the project, it only makes it later because you need time to talk to the new guy and bring him up to speed. So it's important to identify what tasks in the work breakdown structure need to be done by when, by who, ahead of time. So it makes tracking and control easier. Otherwise, you run into a situation where one developer says, "Okay, that's another person's job, not my job," and then you run into finger pointing. It's the only way to know what you're doing and what else can be changed, reordered to try to stay on track. So, if the project is slipping in schedule in terms of schedule or budget, diagnose and recover as best you can by reorganizing, changing the schedule, etc. Perhaps if a developer is not competent for his assigned tasks, you can assign him to other tasks that are less demanding, less challenging, or perhaps you can fire him and get someone more competent. So that's the job of a project manager. Sometimes you make difficult decisions. So even if the schedule changes, you should try to identify why first and incorporate this knowledge into measurements for next time. So for the next project, you can prevent these kind of changes. A schedule slip is not good, but understandable if you know why it happened, so that you can prevent it from happening again in the future. So however, missed deadlines with no knowledge of why things are happening, that way is incompetence. Incompetence of the project manager. So if something bad happens, you always have an explanation and a countermeasure for it in the future. So how to do project tracking and control? You hold periodic project status meetings weekly or monthly. Typically, weekly meetings are normal in a project team. Do project reviews and evaluate results of each review. So, review the progress of the project, perhaps weekly or monthly. Check if milestones are accomplished as planned. Milestones include deliverables like requirements documents for design documents for a particular build. Compare the actual budget with the planned budget and the actual start date with the planned start date for activities. That's based on your Gantt chart. Have informal chats with project staff to obtain subjective assessment of the progress up to date and problems on the horizon. So, project management is all about people management in addition to technical parts. So a summary is to manage the process. Don't let the process manage you. That is, you should try to keep in control of the process instead of using the process as the recipe and stick to the process rigidly so that let the process manage you. So this is the CEO of a local company. Okay, so that's the end of project management. So the slides I presented today have some extra slides beyond what you have on the website. I'll post the update of the slides later. Essentially, adding more details on the PERT chart and the metrics estimation based on metrics. So next few classes we'll do some reviews for. I think I'll spend 2 classes on doing a end-to-end from the beginning review of major concepts, and finally a last class on some sample questions. So with your PRS. So your peer reviews are due. I will grade your activity 2 today, and you'll be able to pick them up tomorrow or at the class time on Wednesday.